Good morning to all of you. I will be teaching you computer networks. First, we will talk about the fundamentals of data communication and networking. What is data communication? Data communication are the exchange of data between two devices via some form of transmission medium such as wire cable. The transmission of digital or analog data between two or more devices or nodes within a network is data communication. This encompasses the entire process from source to the destination. Importance of data communication. It forms the bedrock of all modern communication systems, including the internet, mobile networks, and automation systems, enabling global connectivity. The application area of data communication network is crucial for emerging technologies such as Internet of Things, smart grids for efficient energy distribution, and robust industrial communication. Then I will talk about the components of data communication. Components are message. What is message? Message is the actual data or information to be communicated. The popular form of information include text, numbers, pictures, audio and video. The second component of data communication is sender, a device that originates and transmits the data. The sender can be computer, workstation, telephone handset, video camera and so on. Then we talk about the receiver. A receiver, a device that receives the transmitted data. It can be a computer, workstation, telephone handset, television and so on. Medium. This is the physical path through which data travels, such as wires, fiber optics or airwaves. Next component is the protocol. Protocol is a set of rules, predefined rules that govern data communications. It governs how data is transmitted and received, which ensures proper interpretation. It represents an agreement between the communicating device. Data representation. Digital data, it can be represented as binary digits, bits, which is nothing but sequence of zeros and ones, forming the fundamental building blocks of all digital information. ASCII, it is a 7 or 8-bit character encoding standard assigning unique numerical values to letters, numbers and symbols. A is represented as 65. This ASCII is the American Standard Code for Information Interchange. ISO and Unicode, more expansive character sets supporting multilingual representation. It is crucial for global communication. It addresses the limitations of ASCII code. Data can be represented as images. These images are also represented by bit patterns. In its simplest form, an image is composed of matrix of pixels, where each pixel is a small dot. The size of the pixel depends on the resolution. For example, an image can be divided into 1000 pixels or 10,000 pixels. After After an image is divided into pixels, each pixel is assigned a bit pattern. The size and value of the pattern depend on the image. Then audio data. Audio refers to the recording or broadcasting of sound or music. It is different from text, numbers or images. Even when you use a microphone to change voice or music to an electrical signal, we create a continuous signal. It is converted from analog to digital via sampling and quantization. It captures the sound waves and visual frames into digital streams. Data flow. The communication between devices can be simplex, can be half duplex, or it can be full duplex. In simplex mode, the communication is unidirectional, as on a it looks like a one-way street. Only one of the device on a link can transmit and other can only receive. So data flows in only one direction from sender to receiver. Example is the traditional television broadcast. Keyboards, traditional monitors are all example of simplex device. The keyboard can only introduce input, where the monitor can only accept output. In the simplex mode, it will use the entire capacity of the channel to send the data in one direction. In half duplex mode of data communication, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive and vice versa. The data will flow in both the direction but not simultaneously. In half duplex transmission, the entire capacity of a channel is taken over by whichever of the two devices is transmitting at that time. The example is walkie-talkies conversations. Half duplex. Now we will talk about the full duplex. In the full duplex, both stations can transmit and receive simultaneously. So data can flow in both the directions at the same time. It allows simultaneous sending and receiving. Example is typical phone call. When the two people are communicating by a telephone line, both can talk and listen at the same time. Network criteria. What is network? A network is a set of devices. Often it is referred to as nodes. They are connected by communication links. This node can be a computer, node can be a printer or any other device capable of sending or receiving data generated by other nodes on the net. Network criteria. A network must be able to meet a certain number of criteria. The most important of these are performance, reliability, security and scalability. What is performance? Performance can be measured in many ways, including throughput data rate, including the latency delay, the bandwidth, which ensuring the efficient and timely data transfer. Reliability. In addition to accuracy of delivery, network reliability is measured by the frequency of failure, the time it takes a link to recover from failure, and the network robustness ensures this reliability ensures consistent service with minimal errors. It is measured by the factors like error rate and connection uptime, which is vital for critical systems. Security. Network security issues protecting data from unauthorized access, modification, destruction of data, encompassing confidentiality, integrity, and availability. It security it also issues the protecting data from damage and development, and implementing policies and procedures for recovery data from breaches and data losses. Scalability. The network's ability to expand and adapt to increased user demand and traffic load without compromising the performance. Understanding the data communication is fundamental to virtually all modern engineering systems and technological advancements. Grasping how data is represented and flows through networks, it provides the essential groundwork for advanced topics. Next, we will talk about the various network types, its different topologies, the different communication protocols, and their practical implications in electrical engineering.